Welcome back. For this lecture, we're going to talk about what work is done when the force varies depending upon the location of the object. And this is really a common occurrence. You don't usually apply a constant force to an object. The typical force is going to vary with either distance or time. So let's go ahead and get started and see how we handle this. Well, here's a graph. It has force on the y-axis and displacement on the x-axis. And we're going to apply a constant force, denoted by the little red line. And we can say that work is equal to force times the displacement, and we can calculate that from position A to position B. And the area under that curve from XA to XB, from position A to position B, can also be used to calculate the work done by the force when it moves an object from A to B. And that's that area under the curve. So the area under the curve is F times the displacement from A to B. And that's our work. We know that as our work. Now how about if you have a curve like this? So in this case, the force varies. It's not constant. It's lower at A than it is at B. We can't use the F delta X form to calculate the work because the force is not constant. Okay, so we have to do another technique to solve for that, and we're going to use the area under the curve. So from A to B, we can still use the area under the curve, but in this case it's not a rectangle, so we're going to have to sum the area, or come up with the area of the trapezoid either by adding a rectangle to a triangle or using the formula for a trapezoid. Okay, so that's the area under the curve that we're interested in. So there we have our rectangle and our triangle. And we add those two areas together, and that tells us the work that's done by the force as the object moves from A to B. Here's your multiple choice. So here's a sample problem, and this is a piecewise function, piecewise force, and we want to know how much work is done by the force when it acts on an object from 0.25 to 0.75 meters. Okay, so I'm going to identify the areas that I'm interested in. So this is area 1, and this is area 2. And that covers the displacement from 0.25 to 0.75. So we're going to calculate the area under the curve. So the area is of this rectangle is force, which is 0.4, times the displacement, which is 0.25, plus the area under this curve, which is the force is 0.8 times the displacement of 0.7, or I'm sorry, it's still 0.25, 25. And we do the math on that. Okay, so 0.4 times 0.25 is 0.1. And plus 0.8 times 0.25 is plus 0.2. So that adds up to 0.3 joules of work. And here's another sample problem. How much work is done by the force shown when it acts on an object and pushes it from 2 meters to 4 meters? So let's go ahead and identify our area. So from 2 meters to 4 meters. Okay, so this is a triangle. The area of the triangle is 1/2 the base times the height. So the work is going to equal 1/2 the base, which is 2 meters, times the height, which is 0.6 meters. And that's equal to 0.6 joules. 0.6 joules of work were done pushing the box or from the object from 2 to 4 meters. And here's your free response. Good luck. We'll see you next time.